So today we're going to review Chapter 3, go through some questions, make sure we have an understanding of everything that was involved in Chapter 3. The best way for you to view this video would be to, when I go to the next slide, you pause it and try each question on your own. And then after that, after you've tried them, think you've got them, were confused, whatever, you can play it and I will help you and I will show you the way to do it just in case you were confused. Or even to check your answer to make sure you were correct. So each slide, pause it, try it on your own, and then play it again from that spot and watch as I go through them. So first thing in Chapter 3 that we're going to review is whether relations are functions or not. So again, right now we pause the video, try A, B, and C, and then start again to see if you were correct or not. So first, if we're telling if something is a function or not, we have to remember the definition of a function. And very important definition of a function is for every input, there is only one output. So each input only has a single output to it. So if we look over here, part A, there's an input of 0, an input of 5, and an input of 6. So since none of those inputs repeat, this would be, yes, it is a function. So part A is a function. And to explain, you can just use the definition of a function. Each input has only one output. This one confuses students sometimes just because they might see this 8 repeat and they think, well, that 8 happened twice, so therefore it's not a function. But the output doesn't matter if it repeats. The output can repeat all day, it doesn't matter. All that matters is if that input repeats more than once and has 2 or more outputs. So, as long as you don't have a repeating input, you are fine. So this is a function. Then we look at B. Again, with a graph, remember, to tell if something is a function or not, you can use the vertical line test. The vertical line test means no matter where you make a vertical line, if it crosses through more than one point on that line, then it is not a function. But with this one, you can see I can make a vertical line anywhere I want on this graph, and it's always going to go through just a single point. Okay, each of these vertical lines only went through a single point. So since there's only one point being crossed through, every time I do that vertical line test, this would be a function. And to explain that one, you just say it passes the vertical line test. Okay, so make sure you understand how to explain them as well because you will have to do that on the test. So, then we have the third type, which is the mapping diagram, where they want us to, once again, tell if it's a function or not. So again, I look at each input, and since each of these inputs have just a single output, this as well would be a function. So actually, all of these would be considered functions. Again, students will get confused because they see this arrow going to both going to 15, but the output doesn't matter. Okay? If you have two arrows going from a single input, that's when it would be not a function because that input had two different outputs. But like I said, and to explain this again, you can just use the definition of a function. Each input, -1, 3, and 11, all only have a single output. So therefore this is a function. So you have to be able to tell in different forms whether something is a function or not. Okay, so that's the first thing to remember in Chapter 3. Next I'll ask you, does the table or graph represent a linear or non-linear function? So there's two choices here. It's not a yes or no question. Is it linear or is it non-linear? And then they want you to explain. So with part A, remember with tables, to tell if it's linear or non-linear, you have to see if it has a constant pattern from one x value to the other and from one y value to the other. Those patterns do not have to be the same from x to y, but all x's have to have the same pattern and all y's have to have the same pattern. And they have to be addition or subtraction, not multiplication or division. I had students get confused with that as well. So let's look at the x's first. So from 6 to 10, you are adding 4. From 10 to 14, you are adding 4. And from 14 to 18, you are also adding 4. So, my x's have a constant pattern of adding 4, so that's good. But then the y's have to have a constant pattern as well. So let's check those. Y, 5 to 9 adds 4. 9 to 14 adds 5. And 14 to 20 adds 6. So as you can see, the y's do not have the constant pattern of adding the same amount each time. So, since these y's do not have a constant pattern, this would be considered a non-linear function. So if it has a constant pattern on both of them, it's linear. If one of them does not, it is non-linear. And to explain, you can just say the table does not have a constant pattern for the y values. So make sure you're understanding how to explain these as well. Part B, the graphs are much easier to tell if it's linear or nonlinear. Remember, linear functions have a straight line the whole time. Okay, it's straight in the same direction the whole time. Nonlinear might curve, they might come to points and go in opposite directions. But as you can see on this one, this is a straight line this whole time. There's no bends, no breaks, no turns. So this is linear. Again, to explain for a graph, you can just say it is a straight line. Okay, because that suffices to explain that. So, part A, remember with tables, check its pattern for both. And part B, you're just checking on graphs to see if it's a straight line or not. Okay, so make sure you can determine whether you have a linear or nonlinear function. All right, next we have to be able to evaluate things in functional notation. So remember, this is functional notation where they have f of x. Remember, f of x is just a replacement for y. Not that it matters in this one, but in the future, remember f of x and y are used interchangeably. This says evaluate f of x equals 4x minus 12 when x equals 7. So here's the important information. X equals 7. So we have to take 7 and plug it in for x in that equation. So what this will look like would be f of 7, because we're wanting to evaluate x when it's 7, equals 4 times 7, because that's what's being plugged in place of x, minus 12. And then we're just doing simple math from there. So f of 7 equals 4 times 7 is 28. Bring down my minus 12. And then f of 7 equals 28 minus 12 is 16. So your answer for that one would be 16. So when they're in that form, all you're doing is taking the value they give you and plugging it in for x and simplifying to get your answer. So next thing we talked about is slope. We have to be able to find slope when we're given 2 points. So remember the important equation or important formula that I told you you have to memorize. For slope, that is y2 minus y1 over x2 minus x1. Again, that is not given to you. You have to know that equation or that formula. So, the way to use this is we have to label our ordered pairs. We have to label them with x's and y's. So remember, in ordered pairs, your first number is always your x. So this is x, 1, and then these are subscripts, remember, just to number your x's and y's. So x1, y1, and then x2, y2. Once they're plugged in, or once they are labeled, you can plug them in. So my y2 is 1 minus my y1 is 7 over my x2 is 11 minus my x1 is 9. So then we're going to simplify. We have 1 minus 7 on top, which is negative 6, over 11 minus 9 is 2. And then if it can reduce or simplify, make sure you do that. This would not be your final answer. because this can simplify. Negative 6 divided by 2 equals negative 3. So your slope for those first 2 points would be negative 3. Okay, let's look at the second one. We're again using that same equation, or same formula, y2 minus y1 over x2 minus x1. I'll come over here and label. X comes first, x1, y1, x2, y2. Then we're going to plug in to our slope formula. y2 is negative 9 minus y1 is 6. Again, you have to make sure you bring that minus sign. The reason is students get that confused and sometimes drop it whenever there's a bunch of negatives involved. x2, negative 7, minus x1, negative 4. So this is a prime example of when students will drop it. They'll just put minus 4, but it's minus negative 4. Equals, and we simplify. Negative 9 minus 6 is negative 15. Negative 7 minus negative 4 is negative 3. So a couple things. First, a negative divided by a negative is a positive. So really, those can go away, because negative divided by negative becomes positive. And then we have 15 divided by 3. We have to check to see if that simplifies or reduces, and it does. So 15 divided by 3 is 5. So your slope for that second set of ordered pairs is 5. Okay, so like I said, you have to know y2 minus y1 over x2 minus x1. That's important for slope. All right, and the last couple things we talked about in chapter 3 is graphing. So this one says use intercepts to graph 2x plus 3y equals 12. So remember, with this is standard form. So remember, standard form ax plus by equals c. That's what form this is in. And that's when you can use the intercepts. You find your y and you find your x intercepts to graph this equation. So this is something students tend to forget. So make sure this is something you remember. So let's talk about how we are going to solve this. I'm making a quick coordinate plane just so I don't have to move over there to the other coordinate plane. So to solve this, remember, if I'm trying to find, for example, if I'm trying to find the x-intercept, no matter where I'm at on the x-axis, the y value is always 0. So what that means, if I'm finding x-intercept, I have to plug in 0 for my y. So what that will look like will be like that. And then we're just simplifying, because 2x, 3 times 0 is 0, so this is just plus 0, equals 12. And then that can just go away, and it's just 2x equals 12. Simplify, divide by 2, x equals 6. So remember, we have to turn that into an ordered pair in order to graph it. So if the x is 6, remember the y in this part was 0, so that's an ordered pair of 6, 0. So that's our first point. But then we try to find the y-intercept, and to find the y-intercept, we replace x with 0. So that would look like this. 2 times 0 is 0, which just goes away. So that would be 0 plus 3y equals 12. 0 goes away. We have 3y equals 12. Simplify by dividing by 3. Y equals 4. So this ordered pair, again, in ordered pairs, your x comes first. The x in this part was 0. And then my y that we found was 4. Make sure you get those in the correct order. X comes first, so 6, 0 here, 0, 4 here. So then, once that's done, we can go over and graph this in their proper spots. 6, 0. When you plot that, you have to go to 6 on the x-axis first. 1, 2, 3, 4, 5, 6, and 0 means I stay on the x-axis. So my 6, 0 point would be right there. 0, 4 means 0 on the x, and up to 4, 1, 2, 3, 4 on the y. So there is my other point. So that's what it means by using the intercepts. Both points are on, one's on the y-intercept, or on the y-axis, and one's on the x-axis. So this is my x-intercept, that's my y-intercept. And then I just draw my line through them. And there's your answer. So this line is your answer. That's the graph that represents this equation, and this is how we get to it. Okay, you'll have 2 of those on the test, so make sure you know how to graph using intercepts. All right, lastly, we have graphing in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. M is your slope, b is your y-intercept. So, when graphing like that, let me draw my coordinate plane back up here. Okay, so when graphing in slope-intercept form, your first point, make sure you hear me on this, your first point comes from your y-intercept. That's where the very first point is made. So my y-intercept, my b, in this, y equals negative 3x plus 6, is what? 6. 6 is your b. That's in the b position of y equals mx plus b. So what that means is on the y-axis, I go up to 6, and that's where my first point is made, on that line. Okay, so on the line, my very first point is made at 6 on the y-axis. From there, we use the slope. Okay, our slope in this problem is in the in position, negative 3. So negative 3 is my slope in that in position. Remember, on a graph, you want to use rise over run. So that means you need an in fraction form. If you're given a whole number slope, to make that a fraction, you change it, or you put a 1 underneath it. So that becomes negative 3 over 1. So my rise is negative 3, and my run is 1. So rise means you're going up or down. Run means you're going left or right, depending on negative or positive. So if we have a negative 3 for the rise, that means from the point I just made, since it's negative, I go down 3 spots. 1, 2, 3. I do not make a point there because I still have to use my run. If my run is positive 1, that means I go to the right 1 spot. So from here, I go right 1, and that is where that point would be made. And I can repeat that process with my slope. Again, down 3, 1, 2, 3, right 1, right there. So my line to represent y equals negative 3x plus 6 would look like this. Just like that. So there is my answer. That is the graph that represents y equals negative 3x plus 6. So those are the main things we covered in chapter 3. Those are the main things you need to remember and things that you need to know how to do in Algebra 1. So, again, if you're confused on any of that, rewatch it. Reach out to me. I'll help you out. But like I said, those are the main points we need to know for chapter 3. Thanks.